Now question number 86. If enthalpy of hydrogenation of cyclohexene is minus X kilojoule per mole and the resonance energy of benzene is minus Y kilojoule per mole, then the enthalpy of hydrogenation of benzene will be. First we need to find out the chemical reactions. One is hydrogenation of cyclohexene. What is cyclohexene? It is an organic compound. Its hydrogenation is taking place and it is giving you cyclohexane, and this case has the enthalpy change is minus X kilojoule per mole. Now the resonance energy for benzene is minus Y kilojoule per mole, and enthalpy of hydrogenation of benzene you have to find out. So if you have benzene and you do the process of hydrogenation, then you will ultimately obtain cyclohexane, and for this reaction you need to find out the change in enthalpy, but resonance energy you have. So I'll write here the resonance energy that is given, because benzene is stabilized by resonance, that's why. So it is minus Y kilojoule mole inverse. Now we can find out the enthalpy of hydrogenation of benzene by 3 into enthalpy of hydrogenation of cyclohexene, because in this case one bond is hydrogenated while here are 3 bonds, so that's why it is 3 into minus X minus resonance energy that is used for stabilization. So in that case it is minus Y. So it would be minus 3X plus Y, or simply you can write it as Y minus 3X kilojoule per mole. And where this answer is given, it is given in option 1. And that's why the answer for this question is option 1. Now let's move on to the next question.
Now question number 87. If 100 ml of 0.1 molar acetic acid and 200 ml of 0.03 molar NaOH solutions are mixed together, then the pH of resulting mixture will be. In this case, pKa value for acetic acid is 4.74 and the log 1.5 is also given, that is 0.18. In this process, first we have acetic acid mixed with NaOH. It's a neutralization process. Salt is formed here. Along with that, water is formed here. Now, if you consider the given concentration, 0.1 is for acetic acid and its 100 ml is taken. So we can easily find out the millimoles using this. We know that initial millimole we can calculate. 0.1 molar solution is there, 100 ml is the volume, so millimoles would be 0.1 into 100, because we know that molarity of a solution is the number of moles of solute present in its 1 liter. So we are taking here 100 ml, that's why millimoles can be calculated, and simply it would be 0.1 into 100, 10 millimole acetic acid. Now what about NaOH? This would be 0.03 into 200, and that is 6 millimole. What about this sodium acetate? These are 0. Now, final millimole, let's check. As per this reaction, 1 mole of acetic acid is reacting with 1 mole of NaOH. It means if you have 6 moles of NaOH, definitely 6 moles of acetic acid were consumed, and the final millimole of acetic acid would be 10 minus 6, so 4. What about NaOH? There would be 0 millimoles, and if we talk about the sodium acetate, 6 millimole of this sodium acetate would be there. Now, the question is to find out the pH value here. Basically, this mixing results in the formation of acidic buffer, because in this case, we have acetic acid and sodium acetate. So basically, it's an acidic buffer, and for acidic buffer, if you want to find out the pH value, that would be equal to the pKa value plus log of concentration of salt upon the concentration of acid. Now, pKa value is already given for this acetic acid. It is 4.74 plus log. What about the millimole of salt? The salt is sodium acetate, it's millimole and 6, and millimole of acetic acid is 4. So this would be equal to 4.74 plus log 1.5, and the value of log 1.5 is already given in the question. So this pH value that you can calculate here is equal to 4.74 and the value of log 1.5, that is 0.18. 4.74 plus 0.18. What would be this value? This would be 4.92. And where it is given? It is given in option 2. So this is the correct answer for this particular question. I hope this question is also clear to you. Let's move on to the question number 88.
Question number 88. Which one of the following salts is least soluble in water? And we have different salts given here in the given options as well as their KSP values given. While the fourth option says all are equally soluble. One thing you should note here, that lesser the value of solubility product, lesser would be the solubility of the salt. And you just have to check the solubility product which is given here. If you check here, you will see that the salt MZ with the KSP value 10 to the power minus 70 has the least value of KSP, and that's why it is least soluble in water. That's why I'll mark here it is the correct option. That is option 3. Now after this, it's turn for next question. Question number 89. Which among the following is a Lewis acid? We know that Lewis acids are electron acceptor, and if we look at the given options, we'll identify that B2H6, it is an electron deficient species. Why it is electron deficient? Because boron is there and its octet is not completed. B2H6, this is the dimer of BH3, and in case of BH3, octet is not completed. That is why this B2H6 is considered as electron deficient species, and that's why it is Lewis acid. While other options, if we consider, the CH3OH does not have the deficiency of electron, while ammonia has one lone pair at nitrogen atom. Similarly, in case of water molecule, there are two pair of electrons are present as lone pair on oxygen atom. So that's why in this case option 2 is the correct option, and that is the answer for this question. Let's take the question number 90. Question number 90. At 300 Kelvin, delta G of the formation of N2O5 in the gaseous state is minus 43 kilojoule per mole. If at a particular instant of time, partial pressure of N2O2 and N2O5 gases respectively are 2 atmosphere, 1 atmosphere and 2 atmosphere, then the value of delta G for the reaction. The reaction is given here. Nitrogen is combining with oxygen to form N2O5. So in this case, we just want to find out the delta G value for the reaction that we have to find out. And we should know that delta G is equals to delta G naught plus 2.303 RT log QP. Now this QP is the reaction quotient. Let's find out the reaction quotient for this. There is a pressure for N2O5 raised to the power 2 divided by pressure for nitrogen raised to the power 2, and the pressure for oxygen raised to the power 5. This is the expression with the help of which I'm just going to find out the QP value. This pressure for N2O5 is clearly given in the question. If you look here, you will find out the partial pressure of N2O5 is 2 atmosphere. This would be 2 raised to the power 2 divided by pressure for nitrogen, that is also 2. And if we talk about oxygen, the pressure for oxygen is 1 atmosphere raised to the power 5. So this would come out to be 1, and this delta G is minus 43 kilojoule per mole, that's given in the question, plus 2.303 RT log 1. What's the value of log 1? That is 0, and that's why this whole expression becomes 0, and yes, this delta G value becomes minus 43 kilojoule per mole, and that's why the correct answer is option 4, and that I can write here. I hope this question as well as all the questions those we discussed till now are clear to you. This is the last question of the chemistry section. Thank you so much for watching.